Page 486, we're talking about the mid-segment theorem and medians, which, by the way, happens to be one of our poster notes. And so if you haven't seen that poster note yet, go back and watch that video. Thank you for the view. And take some notes on it and learn. That's a good snapshot of what's happening in this one. Get ready for a doozy of a thing. You've probably already seen the timestamp and how long this video is. It's going to take some time. To be ready for it, all you need is a pencil or a pen, and you need some highlighters. And then have some extra paper on the side because we're going to do a flow proof together. We'll take the flow proof and in the next video, turn it into a 2-column proof. But this is like the outline, the pre-write, the wrap your mind around what you're supposed to do for the question. And it's going to take some thinking. It's going to take some stick-with-itness. I'm probably going to need more like paper as well, but let's go to this one. Use the diagram to prove this conjecture. Yellow for the proof. Given J is the midpoint of MD, G is the midpoint of MS. So we have J, we have G, we have MD, and we have MS. That's what we're going to start with. Where do we end up? We're going to end up by saying that JG is parallel to DS. We kind of already have that. We have that like from what we did in the previous video. Go back and watch page 485 if you haven't yet. And then we have JG is equal to half of DS. So there's like a 1/2 or a 1-to-2 relationship between those sides. If you don't believe me, you can also start by taking your highlighter out, or not highlighter, your ruler out and measuring. That's approximately 12 millimeters, and then this is approximately 24 millimeters. So there is a way to prove it by observation. But we got to do this formally in a proof format, and there's just not enough space on this paper, so I've brought in the extra copy. Now, we start by saying the given. J is the midpoint of MD. G is the midpoint of MS. We have to do that first. That has to be given in the very beginning of the problem. Given is the reason for that one. What we need to do after that is then to figure out, well, what does that mean about the information, the pieces that we have? And as I'm looking at this here, yes. Okay, let's go right away into what it means to be a midpoint. So our next reason is going to use, I'm going to add some color. It's going to use this vocabulary word with that letter, and it's going to use this vocabulary word with that letter. So I'm going to put that over here. JM is congruent to JD. I want to say this together in the same place, so GS is congruent to GM. Since we put two statements together there, I'm going to put, two statements together over here, and the reason for this box is because definition of mid. Okay, connected. That's our first flow proof branch stemming from the given statement. If we ever see a statement that has a vocabulary word in it, then it's an automatic push that out in that direction to see what that can tell us. Something else that I want to acknowledge is because of the way it was constructed, this is constructed to be a mid-segment. So JG is a mid-segment of a triangle MDS. Okay, so wrap that up, and we're going to put, what's the reason for that one? Well, a mid-segment joins the midpoints. We have this midpoint happening. So the midpoints create mid-segments. Mid-segments join midpoints. Okay, so that's the reason for that one. Okay, always I'm putting the statement and the reason together. It's going to really help on page 487 when we start to outline and organize, take the outline and organize it into a list. Okay, so we're pushing towards showing the lines are parallel. I almost feel like we can show the lines are parallel right now because there's going to be a proportion that we can use the triangle proportionality theorem to show that this line is parallel to this one, and it's all based upon proportions. So I gotta get there with a little bit of a leap, and the little bit of a leap is this. dj plus mj equals md. Now I have to do, oops, I wrote it here. I have to do this because I have to eventually set up the proportion, and I just can't make the top MD of the proportion just pop out naturally. It has to be established through some rigor proof. But this is, segment addition. Likewise, for the same reason on the other side of the triangle, SG plus GM equals SM. SG plus GM equals SM. This is because segment addition is happening. That's a postulate, by the way. And it's happening as well because over here on the side, we're just looking at the diagram. So there's like a diagram option. I'm not really gonna count it, but where'd that segment addition come from? Well, it came from the fact that we're breaking apart the triangle the way that we are, and then we're bringing it back together. Actually, it's not that arrow. It's directly from here. Okay. Somehow, these three boxes are going to form something. Let's see what else we can get from them to form them. If I notice MJ is the same as JMJD, these are just, I switched the letters around. I probably shouldn't have done that. It should probably be JM like this one and JD like that one. But because they're the same with substitution, this gets to say, with this helping it, that JM plus JM equals MD. And for the same reason, since GS, I don't know why I switched the letters here. I should say GS, and then I should say GS again. Brain fart. Okay, GS and GM are the same. So GM plus GM equals MS. All right, here we go. This is because of substitution. Now, if we are adding two things together, can't we just say we have two of those, right? So follow the arrow, follow the arrow. We haven't done anything with this one yet, but at least there's a little bit of overlap. So this one's going to now say 2JM equals MD and 2GM equals MS. We're just adding, right? When you add things together, we're going to collapse the expression of JM plus JM down to 2JM because we're adding. Okay, LeBrant, where does this go? How are we using this? All right, this is what we're going to do, though. We're going to take all of those statements so far, and I'll give this snapshot of everything. I'm going to do a little division right now. I'm going to divide both sides by 2. So if I divide this side by 2, and then I divide MD by 2, we wind up with this. JM equals 1/2 MD. Yo, that's it right there. Okay, GM equals 1/2 MS. This is just using division. Okay, checking again. Yep. So JM, and we have MG, and then we have the half. Okay, somewhere out of diagram also happens, this is a pause. We're going to put a pause right here on this one. It's going to be used in a minute. But also I'm going to say we're trying to set up the prove that 1/2 showed up, and at this box we're almost there. It's almost ready. Okay. We have established proportions, though, I'll tell you that. We've established a proportion that there is a 1:2 proportion between those sides. Hey. Okay, also by diagram, angle G is congruent to angle G. Angle G. Angle M. I gotta read better. Angle M is congruent to angle M. The reason why I had to check myself as well, I'm looking for the angle M that's the same angle in both triangles. So angle M is congruent to angle M. That's reflexive property. We have to say this one because the diagram is creating two triangles, and the diagram is creating the angle that is the same angle in both of those triangles. Because it's overlapping. This small triangle is overlapping. It's lying on top of the bigger triangle. Now what? Now what? Now what? Oh, these two sides. This is a proportion. So little jm to long side md, that's a proportion. Little mg to long side ms, that's a proportion. In it's 1 to 2. So we have the triangle JGM is similar to the larger triangle DSM. So this is a pair of sides. This is well, two pairs of sides technically, and then this is a single pair of angles that is included between the two sides. So by SAS similarity, those two triangles are similar, and if those two triangles are similar, by the triangle proportionality theorem, those lines are parallel. So two things happen here. JG is parallel to DS because corresponding angles in like that angle and that angle are corresponding, therefore they have to be congruent. Let's see. Oh, I'm skipping. Sorry, skip. I got ahead of myself. I'm almost ready to say it. There's one step in the middle that's missing. Let's break this arrow and come back over here with that. Angle. This is why I messed it up. I need to say the angles up here. These are corresponding angles. Time to go back to the diagram and add. We're going to add an angle there and an angle marker there. Those are the same. Since the triangles are similar, corresponding parts of similar triangles, corresponding angles of similar triangles are congruent. So angle MJG is congruent to angle MDS. That's what we get from this box. Not over there. Skip that branch. Corresponding angles in similar triangles are congruent. Okay, there we go. That's our reason. Which then tells us, okay, now I'm ready to say it. JG is parallel to DS. And the reason for this is corresponding angles are congruent. Corresponding angles. And then last of all, because the triangles are similar, then this is still, this is an outline. It's going to look messy. We're going to clean it up for the two-column proof. But it does show this flow through, like it's keeping track of everything that might be missing. Because the triangles are similar, then that means that corresponding sides have to be in a proportion. So I'm at blue in blue highlights. I've just shown this blue highlight when I said this box down here. Now I'm about ready to finish the video, finish the proof with this one. JG is equal to 1/2 DS because corresponding sides, we have similar triangles. When we have similar triangles, the angles are the same and the sides are in proportion. So corresponding sides of similar triangles are proportional. Okay? Yeah, that did it. There's the blue statements. There's the blue statements. And it all, from the entire gigantic web of all of this, came from J is the midpoint, G is the midpoint, which was given. Here's the entire snapshot of the entire thing. Again, shaky cam. Hopefully I can hold it steady for you. Let me hit a quick little focus on it. Not bad. Of course, I have this page in my notes, so if you ever need to see it, come in and check with me. Thank you so much for watching this video. The next thing to do is to take the flow proof and write it in a two-column proof. Why don't you see if you can actually skip page 487 video? I mean, if you don't and you auto-click and you go to the next one, that's fine. But, honestly, now that you've done flow proofs, you should be able to see how to write them into a two-column proof. You got this. I believe in you. Believe in yourself and get this done. See you in the next episode. Whoosh.